Hey everyone, thank you for joining us today. Welcome to the latest in our 2023 Pain Point Series webinars. My name is Claudio Palais and I'm a Senior Content Manager for NetBrain. Today's webinar is about avoiding the perils of network configuration changes. As is typical of our webinars, after our presentation we'll answer some questions from you, the audience. So if at any point during the presentation you have any questions, please do enter them in the chat window and we'll do our best to answer them. This webinar is being recorded, so you can rewatch anytime from our website. Before we get into it, I wanted to talk a little bit about NetBrain. Founded in 2004, NetBrain is the most widely adopted network automation and visibility platform today. More than 2,500 of the world's largest enterprises and managed service providers use NetBrain to simplify network management tasks, reduce MTTR, and provide a top-down understanding of how the network supporting their business works. Why NetBrain? NetBrain's automation is intent-based and 100% no-code, meaning teams adopting NetBrain don't have to invest time and resources developing software or scripts. If you understand your network design and know how to manage it via CLI, you know how to automate using NetBrain. Whereas typical code-based automation consists of device-level scripts, NetBrain automation is built on a network-level understanding of your infrastructure. Network intents digitize how your network should behave. The abstractions facilitated by network intents make it easy to scale your network operations. One intent can be replicated across your entire network or any subset of the network. None of which would be possible without NetBrain's vendor-agnostic, holistic view of the network. Our digital twin and dynamic maps are built from live forwarding data of your network, whether that be traditional, virtual, software-defined, or even cloud. This webinar is part of our ongoing Pain Point series, where each month we tackle a common pain point in network operations and how we utilize NetBrain to address them. Earlier this year, we covered network security and automated diagnosis. Last month's webinar, Adopting Proactive Automation, is available on demand from our website. So if you missed it, we encourage you to check it out. Our engineer Nazanin demoed how triggered diagnosis automation can transform the NetOps incident workflow. And in the following months, we'll tackle hybrid network visualization and outage prevention. Be on the lookout for those and be sure to register. Today, we explore the topic of change management. As a former network engineer, I know there is nothing more perilous than making changes to a production network. I've seen even the smallest of changes take down network behemoths. We discuss those risks and challenges encountered during the typical network change workflow, as well as how to overcome them with NetBrain automation. And later, we'll show you in a live demonstration just how our change management module removes the uncertainties surrounding the dreaded change windows. And as you'll see, network change management with NetBrain isn't just about automating change execution. It's about protecting your network from unintended consequences and enforcing your network's critical designs. NetBrain transforms the entire network change management workflow. Let's start with the typical change workflow. It usually begins with identifying a change is needed and planning for it. Careful planning is important because any small change to production could have massive consequences. And right from that beginning, we run into dangers. It's tough to properly plan with poor visibility into the network and lacking documentation. If you're not sure what's in the network or how it's built, you can't know how your changes will affect it. In hopes of catching any oversights, most organizations have some sort of peer review process. It should be thorough, organized, and exhaustive. But again, if everyone is working off the same faulty information, the risks are only propagated throughout the process. Next in the process, assuming change approval, is pre-change validation. With the size and complexity of current network designs, the impact of changes can be unclear, meaning that whatever baselines of verifications we attempt may not capture all the relevant states and metrics that could be affected by the change. Like the planning stage before it, this danger propagates throughout the rest of the process, since incomplete pre-change validation mean that post-change validation might not catch all the effects of the change, which means unintended consequences. Now comes time to implement the change. Because we must always have the network available for our customers, internal or external, when they need it, change windows are very limited in nature, usually off hours and for short durations. This can make complicated or lengthy changes almost impossible, rushing your engineers and opening up doors for more mistakes. If they run into any hiccups, there's not much time for troubleshooting, lessening the likelihood of success. And should the change be unsuccessful, rolling back is yet another challenge. Rollback is oftentimes more complex than the change itself, and you should always anticipate how long it would take to roll back to establish the point in the change window when aborting the change is absolutely necessary because of time constraints. Lastly, succeed or fail, teams should always document their experiences, actions taken on the network, and any new design. This is typically handled manually, not just in creating the documentation, but also in consuming it. Even assuming change engineers diligently jotted down every relevant note from the change window, future engineers must dig through libraries of documentation for relevant information, a recipe for easy misses and oversights. How is this working out for organizations across industries? Not very well. Uptime Institute, in their 2023 annual outage analysis, discovered that configuration and change management errors caused 45% of all network outages. And they estimate human error, even when not the direct root cause, plays some role in 2/3 to 4/5 of all data center outages. The industry recognizes this and knows change needs to occur. In a yearly survey, an overwhelming majority of IT leaders say outages could be prevented with better configuration processes and management. That's where NetBrain's intent-based no-code automation comes in. NetBrain recognizes that configuration change is a major source of outages and headaches for network operations teams. NetBrain's change management aims to enhance and transform the change workflow to prevent outages and significantly increase the likelihood of success. We call that protected change management. Right from the beginning of the change process, NetBrain enhances the planning stage with dynamic maps to visualize the area of the network being modified. This is where the beauty of NetBrain's network intents come in. Network intents capture how the network is supposed to work. It's literally the network design digitized. From the map, you can identify all the intents previously created for this section of the network and use that understanding to carefully plan out your change, identify scope, and properly analyze the risks. The change can then be defined within NetBrain for peer review and execution. NetBrain facilitates that with built-in approval mechanisms. But if your organization already has an existing tool for network configuration and change management that you'd like to continue using for the approval process, NetBrain integrates with them as well. Pre-change, you can automate any validations and baselining that can then be compared against post-change. This stage can also be enhanced with anti-drift intents for protection against unintended consequences. We can use those intents found during the planning stage and run them as pre-change checks for baselining how the network was behaving before the change. After the change, we can run them again to ensure that intents that shouldn't have been affected by the change aren't. For the actual change deployment, NetBrain eliminates errors by automating the actual execution of the change. Not only does this protect from human error, it significantly speeds the change operations, allowing for more complex deployments in shorter change windows. And if the post-change verifications indicate an unsuccessful change or adverse side effects, NetBrain makes it easy to roll back with one click. In the last stage, NetBrain can automatically export the entire change runbook to Word, all the steps and all the results, instant documentation. But I also mentioned earlier that most documentation is manual, both in how to produce it and how to consume it. With intents, NetBrain allows you to document exactly how the network is designed and lets you consume that documentation with automation. Those anti-drift intents that we were utilizing before to avoid negatively affecting unrelated network design can be updated to include our new change design so that when future changes are deployed, our current change is protected from being overridden or compromised. So let's see it in action. In this demo, we will utilize NetBrain to execute precise changes without errors, eliminate unintended consequences and side effects, and protect the new design from future changes. All right, so let's open up our screen. Okay, so here we have the NetBrain application. And the scenario that we're running is as follows. Our IT team recently deployed a new WebEx server. Now they require our networking team to modify our firewall rules to allow that traffic. So what we've gone ahead and done is on the right side of the screen, we've actually mapped the path from the user access network, represented at the top left by the management PC1, all the way to the WebEx server at the bottom right. And you can see the two HA firewalls in the middle of the path. On the left, we have the actual change steps from our actual runbook. With NetBrain, you're able to maintain a library of change templates. This runbook was created from one of our templates, and we just modified it to fit our purpose. As you can see from the top of the runbook, this change has already been approved. which means it's gone through the formal review process and officially approved for implementation within the system. So let's inspect the first node in the change runbook, which is the change definition. We need to add these new ACL commands to each firewall to allow traffic to destination 10.8.1.26, which is the WebEx server. And all we had to do was input the CLI commands right into the runbook. And now it's automated. That's what we mean by no code. If you know CLI, you're ready to automate any change with NetBrain. No coding or scripting necessary. We can see that the second and fourth nodes in this runbook are the pre-change and post-change benchmarks. But for the purposes of this demo, let's skip ahead to executing the change with automation. NetBrain is going to log into both firewalls and add access list 88. The first firewall is complete, and now we wait for the second. And now we see the device change execute successfully. Error-free change execution is the major part of NetBrain's protected change management. Let's proceed to our post-change validations using intents. We've created intents to validate that our change completed successfully. The first intent verifies access list 88 was successfully configured on both firewalls. Both active and standby firewalls have the new command, so the intended change was made. Now we have an intent that verifies the intended effect. Is connectivity to WebEx allowed? We have pings to the WebEx server destination 10.8.1.26 from the user access network. And from this window, we see that ping was a success. This accomplishes the first goal of this demo, which was to ensure that the change accomplishes what we intended. So now we go to the second goal in our demo, which is to ensure the change has no unintended consequences. So how do we hope to ensure that? Well, it can actually be quite simple. We check to ensure that this change does not violate our critical design rules. What does that mean? Well, in this NetBrain environment, we've maintained a list of network intents capturing our most critical design rules. In this case, that list is maintained within a network intent cluster. So this cluster can be executed at any time, either the entire list or some subset, to enforce our design rules and make sure we never violate them when making a change in the network. You can get a glimpse of what this means from the screen here. Our first intent is our ASA pair symmetry check, which verifies that our HA firewall configurations are always perfectly synchronized. You can see how important that is. A backup firewall is of no use to anyone if it doesn't completely mirror the primary firewall. And this is the kind of unforeseen side effect that might take weeks or months after a change to become apparent, when a failover happens and the network behavior changes because that backup had different rules. Why wait for a failover in production to mitigate something that could have been easily prevented? You can see the cluster has some other checks, like an ACL consistency check and a route confirmation check that monitors crucial routes needed on our network for service delivery and performance. Does our change modify behaviors it wasn't supposed to? That's the point of this intent cluster. So let's run this check and make sure that our new change hasn't violated any of our critical design rules. As we'd hope, our change is free of unintended consequences, another major step in protected change management. Let's click on one of the intents to get a closer look. We can see from our firewall symmetry intent that our change did not violate that. Both firewalls are still compliant. So the next thing we could do to verify any unintended consequences is do a general application path check. Here we gather some of our most important paths from our path library, checking connectivity from source to destination to make sure that our firewall modifications didn't affect any crucial traffic. And we see that our critical apps are still functional. These are the types of verifications that too often change windows go without, and when they are included, could take too much time or require participation from other teams from within your organization. NetBrain automation makes it easy to include these intent verifications in every configuration change and can yield results in seconds. Seconds to obtain the peace of mind that your changes did not negatively impact other parts of the network. So now that our change was successful and is part of the network design, how do we protect its intent from future changes that might impact it negatively? We add our new design as a network intent to our critical design intent cluster from before. When the intent cluster is used in the future, our firewall design will be validated along with the other critical rules. The first step was to create a network intent, which we've done here, that verifies ACL 88 is configured on the firewalls and validates access from the user network. Again, without any coding. This requires two diagnoses. The first diagnosis checks ping connectivity from the access VLAN to the WebEx server. Here you can see some of that logic. If the ping success rate is 0, then there's no connectivity. If it's less than 100, then there are drops. Finally, if it is 100, then the test is successful. The second diagnosis checks the firewall configuration, verifying the ACL is present. The logic here is simple. It's just a compare of the current config with the baseline config. With the intent built, we can now add it to our critical design network intent cluster. Let's open up the cluster manager, search for the critical design rules, and add our newest intent to the list of member intents. We search for our latest intent and click OK. Let's quickly run it to make sure it's working. And of course, since we just made this change, the intent check succeeds. Now, when a change engineer executes a new change, the critical design intent cluster can notify us and them if their change has compromised our firewall design. The last step in our protected change management. This marks the end of the demo. I hope this illustrated the power of change management automation with NetBrain. If you have any questions, be sure to put them in the chat so that our engineers can answer them for you. Now, before we get to the Q&A, we wanted to thank you once again for joining us, and also wanted to share the scannable QR code that will direct you to our website where you can schedule your own demo or check out our new guided tours at your own pace. And with that, let's get to the Q&A. Let's give it a few seconds for questions to come in. Okay, here's one question. Nazanin, what if we've already created or prefer Ansible scripts for a change, but still want to use NetBrain for verifications?
Yep. So you can actually load Ansible playbooks into the main into the change management via one of our built-in actions that we have.
Okay, cool. And here's another one. What about devices managed by API like Cisco ACI?
So NetBrain has integration with Cisco ACI and devices managed by API.
Okay, so you could plan the change with those devices as well.
Yes.
Cool. And there was mention of the runbook templates, but this viewer is wondering if there are templates for the configurations, the change definition.
So you can create a runbook template, and inside the actions, there will actually be a template icon where you can go and choose from templates.
But can you load like templates like for the actual change definition? Can that be templatized?
I believe so, yes.
Okay. Is this another question is this an additional cost module?
Currently, the change module is an additional cost module. Yeah.
I have a follow-up for that one. I don't know if it's a question really, but just a statement, right? But change management module is the only module that could actually make changes to your network, right? All the other automation that we do, for the reasons of protecting your network, right, are only like view commands or show commands, right?
That's correct.
Okay. Just trying to give it a few more seconds for more questions to come in. Well, I think that's it for the questions. So I think that about wraps it up for the Q&A. If you're looking forward towards our next Pain Point Series webinar, be sure to join us next time. And until then, thank you and goodbye.